Matrix addition requires that the dimensions be equal. Rows by columns. You don't say times, it's rows by columns. Rows by columns. 2 rows, 2 columns, 2 rows, 2 columns. The answer is going to be 2 rows and 2 columns. And you add matching positions, this corner with this corner, this corner with this corner, this corner with this corner, and with this corner with this corner. This is the result. Matrix subtraction, you also do exactly the same, but you're going to subtract. It requires that you have the same dimensions. These are called the dimensions. This is a 3 by 3 minus a 3 by 3 will give you a 3 by 3. You subtract matching positions. So it's 1 minus a minus 2, 2 minus 3, 3 minus 0, and so on. Scalar multiplication involves a number times the matrix. This is the easiest. It's that number times each one of these inside. 6 times 5, 30, 6 times 4, 24, and so forth. Matrix product and inverses are a little bit more involved. In order to multiply two matrices, you write the dimension first, and then if these middle numbers are equal, it can be done. If these middle numbers are not equal, it cannot be done. And if it can be done, then the outside numbers give you more information. They tell you your answer is going to be a 2 by 2. To multiply matrices, the one on the left, you look at the rows, and the one on the right, you look at the columns. It's the row times the columns, the row times the columns. And it's the first of the row times the first of the column, the second of the row times the second of the column, the third of the row times the third of the column. Then you start the whole process. It's going to be the first row times the second column. So this one is the first row times the first column. Notice you multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. You simplify those multiplications, and now you just need to do the addition. So you add these numbers, that gives you a 29. You add these numbers, they give you a negative 12. Excuse me, a negative 2. You add these numbers and give you a negative 18. You add these numbers and give you a 12. And notice we got a 2 by 2 the way we knew at the beginning. This is more practice because these look kind of weird. So this one is 1 row, 4 columns. It's a 1 by 4. This one is 4 rows, 1 column. Notice the middle numbers are the same, so we'll be able to multiply them. Our final answer is going to be a 1 by 1. A 1 by 1 will be just a number. So again, we follow the same procedure. The first one of the row times the first one of the column, the second of the row times the second of the column, the third of the row times the third of the column, the fourth of the row times the fourth of the column. So it's a times, plus. So it's 3800 times 20 plus 130 times 180 plus. So now you simplify and you end up with this number. This is the product. It's a 1 by 1. It's just one number. Now, right here, we're going to be getting ready to talk about inverses. Inverse is the idea of reciprocal. Notice a number times its reciprocal is 1. A number times its reciprocal is 1. So a number and its reciprocal when multiplied equal 1. In the matrix world, it's a matrix times its inverse will give you I. So the I is like your 1. This symbol that you see here, that's a symbol for inverse. It's not to the negative 1 power, it's the inverse symbol. So it's A times its inverse equals the identity. It's like saying a number times its reciprocal equals 1. So here, inverse, that's a symbol for inverse. Two matrices are inverses of each other. If when you multiply the matrix and its inverse, you get the identity. Like if you multiply a number times its reciprocal, you get a 1. So how do you determine if these two matrices are inverses of each other? Well, if I were to multiply them and get an I, which is called an identity, it's a matrix. I'll go to the last part before I go to the first. This is what the identity looks like. The identity has ones along this diagonal. We call this the main diagonal. The one that comes from left to right is called the main diagonal. This is also a diagonal, but we use the main diagonal. So the identity matrix would be ones all the way. Everywhere else, there's a 0. So now you multiply these the way you multiply matrices. This is a 2 by 2 times a 2 by 2. It can be done. So it's the first row times these 2 columns, the second row times these 2 columns. You simplify, and if you simplify this, you're going to notice you're going to get a 1 for this, a 0 for this, a 0 for this, and a 1 for this. So it did give us the identity when we multiplied them, so we could say these two are inverses of each other. So these are some clarifications. Matrix multiplication is order sensitive. In other words, if you multiply A times B, don't expect that you get the same answer you multiply B times A. They're order sensitive. They're not like the numbers where the order doesn't matter. Another thing, not all matrices have an inverse, and only square matrices have a chance of having an inverse. You say, well, what's a square matrix? A square matrix has the same number of rows as columns, like a 2 by 2, a 3 by 3, and so forth.